It's longer than the first lesson. I'm not joking. And here we go. Okay, section 1-7. Okay. What we're looking at in this section is proofs, proving statements. Okay. So, what we're going to do is first look at an algebra proof, which is a basic proof. Okay, Mia, turn around, please. All right. So, what we're given at the start of the problem is 6 times the quantity 14 plus x equals 108. What we were given, the reason that it is there is it is given to us. Okay? So the first statement generally in an algebra proof is given, and always in an algebra proof and generally in a geometry proof is given, but not every time. Okay? Then what property is it did we do to go from there to there? What is this that we just did? Distributive property. And then from here to here, what did we do to both sides? Subtracted the A4, so that's the subtraction property. And then from here to here, what do we do? Well, we combine like terms. And then from here to here, what do we do to both sides? Haley Taylor, pay attention. Division property. Okay? So, this is our statements column. Statements column. And our reasons column. This is what we call a 2-column proof. Okay? So that's one for algebra. Okay? Let's look at one for geometry. But before we do the geometry one, here's a vocab word. A theorem is a conjecture that is proven. Okay? A theorem is a conjecture that is proven. Now, our first theorem in geometry is vertical angles are congruent, which says angles 1 and 3 here are the same size as each other. Angles 1 and 2 here are the same size as each other because they're opposite angles. Opposite angles are congruent. Why? Well, we're going to prove why that is in a second here. Okay. We're given that angle 1 and angle 2 are vertical angles. We're supposed to prove that they're congruent. So I'm going to write as my first step, angle 1 and angle 2 are vertical angles. Why am I writing that? Because that is given to me. Then, because they're vertical angles, then what I'm going to need to say is angle 1 and angle 3 are a linear pair. And then also angle 2 and angle 3 are a linear pair. Now, we haven't defined a linear pair yet, but what a linear pair is two angles that make up a straight line. Two angles that are on a straight line. So that is the definition of a linear pair. Now, linear pairs, there's a theorem about linear pairs that say linear pairs always add up to 180 degrees. So angle 1, the measure of angle 1 plus the measure of angle 3 add up to 180 degrees. The measure of angle 2 and the measure of angle 3 add up to 180 degrees. What that is the linear pair theorem. That all linear pairs add up to 180 degrees. Okay, again, we haven't gotten there yet. We'll get there later this section in the theorems and other things like that. So now that we have that, I'm going to look at this. Since this is equal to 180 and this is equal to 180, since they're both equal to 180, I can set them both equal to each other. So when I replace 180 with another one, you could say transitive property if you want, or you could say substitution if you want. Transitive property is if the first equals the second and the second equals the third, then the first equals the third, kind of like the law of syllogism. Or you can say substitution. We replaced 180 with what 180 is equal to in another thing. Now, I'm going to throw something else at you. We've seen this one time this year. Does anybody know what this property is called when the exact same thing appears on each side of the equation? I mentioned it one time for like 10 seconds this year. It's one of our properties. It's called the reflexive property. And then what I'm going to do is this. I'm going to take this minus this to get this. I'm going to take step 4 minus step 5, and it equals step 6. When you minus, what's another name for minus? That's the subtraction property. And finally, what I'm going to say in the end is angle 1 is congruent to angle 2 because if their measures are equal, then they're congruent to each other. That's a definition of congruent angles. The definition of congruent angles. Okay? Now, you won't have to write out a proof like that by hand in here. All of yours will be either like drag or drop or multiple choice or different things like that. Okay? So you'll have the answers there. You'll just have to pick out the right answer. But this one, that one is how a two-column proof is set up. Let's look at another two-column proof. We're given that 1 and 2 are congruent to each other. We want to prove that all 4 of these are congruent to each other. Okay, how are we going to do that? Well, we're given 1 is congruent to 2. Now, why are 1 and 3 congruent to each other? What did we just talk about, Mia? What's a special name for that was just up above? What types of angles are they? Starts with a V. They are vertical angles. Okay? Vertical angles are the name that we need to use. What do we know about 2 and 4? What types of angles are those? Vertical angles. Now, since 1 is congruent to 2 and 1 is congruent to 3, then we know that 2 and 3 are congruent, right? And since 2 is congruent to 3 and 2 is congruent to 4, then we know 3 and 4 are congruent. So if 1 is congruent to 2, that makes it congruent to 3, which makes it congruent to 4. So they're all congruent to each other by the transitive property or substitution. Okay? Because one leads to another, leads to another, leads to another. That's a two-column proof. Now, we don't need a proof to solve this one. We just have to use our brains. Okay? If this angle here is 11 degrees from the middle to the top, and if we go from the middle to the bottom, then that's another 11 degrees. How many degrees would this angle be over here? That forms a vertical angle with it. How many degrees would that whole angle be over there? What do you think, Caitlin? About 22 degrees. Yeah, that's a 22-degree angle. Because if this is 11 and this is 11, they add up to be 22. And vertical angles are congruent, so x would be 22. So how would we figure out x here? What would we do with those two expressions? What would you do with the two expressions to figure out what x is? Cambry, what do you think we'd do? No idea. You would just start plugging in maybe one works, maybe two works. Wouldn't that be kind of hard? Yeah. So what should we do? It's algebra. We gotta remember the algebra. What did we do back in algebra, Jordan?
Make the equation of 3x plus 31 equals 4x minus 13.
Yeah. Vertical angles are equal to each other, so we make an equation so they're equal to each other. Okay. Now, how do we solve that equation? What's my first step of solving that, Chase?
You subtract 31, or
What do we move first in general? Numbers or variables? Variables. So which variable should I move? The 3x. We move the smaller variable in general. So subtract 3x from each side. So 31 equals x minus 13. Then what do I move, Micah? You add 13 to both sides. So you get 44 equals x. So if x equals 44, how big is that angle? Well, you have to take 4 times 44 and then subtract 13 from it. 4 times 40 is 160. 4 times 4 is 16. So 160 plus 16 is 176. Minus 13 is 163. Now to check our answer, take 3 times 44 and add 31 to it. Well, 3 times 40 is 120. 3 times 4 is 12. 120 plus 12 is 132. If we add 31 to it, we get 163. If the answers don't match, you did something wrong. That angle is 163. X is 44. All right, so all our theorems. Here we go. We're going to throw like 5 or 6 theorems at you all at once here. The congruent supplements theorem says if two angles are supplementary to each other, like angles 1 and 2, if this is 30 and this is 150, and then two other angles are supplementary to each other, like 2 and 3 are supplementary to each other, that makes the two angles that are supplements to the same angle congruent to each other. So if this is 30 and this is 150, and this is 150, and these are supplementary, this has to be 30. Well, since this is 30, this is 30. Okay, that's the congruent supplements theorem. That's just one of our theorems. Okay, so that's the congruent supplements theorem. Now we're going to look at the congruent complements theorem, which says if 1 and 2 are complementary and 2 and 3 are complementary, that makes 1 and 3 equal to each other. Okay, it's the exact same as the congruent supplements theorem, but now it's dealing with complementary angles. So if two angles add up to 90 degrees, and these two add up to 90 degrees, and this is the same angle, then these two must be equal to each other. Okay, lots of lines drawn there. Okay, so we got the congruent supplements theorem. If they're supplementary, if 1 is supplementary to 2 and 2 is supplementary to 3, 1 and 3 are congruent. Congruent complements theorem, if 1 is complementary to 2 and 2 is complementary to 3, then 1 and 3 are congruent. So what they did is they say, hey, there's another way to do a proof called a paragraph proof. In a paragraph proof, the statements and reasons are in sentences rather than two columns. When I grew up, way back when, a long time ago, the only proofs we ever did is 2-column proofs. Now we'll do paragraph proofs and flow proofs in here. Okay, so there's 3 different types of proofs that we'll do in here. So in a paragraph proof, the statements and the reasons are connected in sentences. And they did a paragraph proof for the congruent supplements theorem, which says, well, when we have supplementary angles, they add up to 180. So since 1 and 2 are supplementary, they add up to 180. Since 2 and 3 are supplementary, they add up to 180. Since they both equal 180, we set them equal to each other. And then if we subtract 2 from each side, kind of like what I did before in that vertical angles one, then I get angle 1 equal to angle 3, so then they are congruent to each other. So that is a paragraph proof. Okay, theorem 1-4. If you don't understand this, you're not going to ever understand geometry. All right angles are congruent. All right angles are how many degrees? 90. So if you have two 90-degree angles, what are they going to be? Congruent. Okay? They're the same size, they're congruent. Theorem 1-5. If you have two congruent angles and they both add up to 180, they both have to be 90. Okay? Two angles that add up to 180 don't especially have to be each 90 degrees. But if you're told that they are congruent to each other and they add up to 180, they both have to be 90. Okay? That's another theorem. The linear pair. The definition of a linear pair is two angles that lie on a straight line. Okay? That are adjacent angles. The linear pair theorem says the sum of a linear pair is 180. And we used that linear pair theorem a little earlier today. The sum of a linear pair is always 180. Okay? Because when you have a straight angle and you have an angle coming off of it, these two will always add up to be whatever the straight angle is, which is 180 degrees. Okay, so now we're supposed to write a two-column proof about this using linear pairs. Okay? Well, we are given that measure of angle 1 equals measure of angle 2. So that is a given. We're also given that measure angle 1 equals 105. So that is a given. So if we look at this, see how 1 equals 2 and 1 equals 105? So since I know that, I can replace and put 2 in the 1 spot because they're equal to each other, so I can put 2 there. Now, you could call this substitution and you'd get it right. You'd also call this the transitive property because if 1 equals a second and the second equals a third, then the first equals a third. Okay, that's the transitive property. So either one, substitution or transitive property, is correct. If something gets counted wrong on a test where you said transitive instead of substitution or substitution instead of transitive, I'll give you points back, but you just have to tell me. Okay? Then we look at the picture and we see 2 and 3 are on the same line, right? So that makes them a linear pair by the definition of a linear pair. And what do we know? Well, right up above, we were told that all linear pairs add up to 180. That's the linear pair theorem. Okay? Now, there will be a test question or a quiz question, either a quiz or a test, I forget. Maybe it's your next quiz, that these two are really important for them. So know them on Tuesday. Okay? You have to know the definition of the linear pair, and it's different than the linear pair theorem. Definition of linear pair calls two angles a linear pair when they're on a straight line. The linear pair theorem tells you that they add up to 180. Now, let's look at this. I said angle 2 is 105 right here. See how I conveniently got rid of the 2 and made that a 105? When you replace, it's called substitution. And then what I do to each side? I took away 105 from each side, which is subtraction. Okay? So that's what proofs are. So, in summary, proofs are logical statements that uses definitions, postulates, theorems, properties, whatever. I could make a two-column proof or I could make a paragraph proof of the same thing. And that's my vertical angles one that I did up above a little earlier. I just did a few more steps. Okay. There is approximately how much time left? You get out at 14. There's a good 20 minutes left. So in the next 20 minutes, you probably won't get quite all the way done with this, but in the next 20 minutes. Let's